Okay, we're going to take a quick look at fractions and introduction lesson. After you've gone through this little training tutorial, you can take a look at the self-test video and work out some fractions and then see how you're doing. That's another video. So we're going to take a look at a couple of quick things here. We're going to see about addition, subtraction, multiplication, and division, as well as improper fractions. Before we get started, we'll take a look at what I'll call fraction nomenclature. That is, what are the parts, the names of the parts of a fraction, so that you'll understand those. In this position, we have something that's called the numerator, anything that's in the position above the vinculum, which is that little line right there. And the fact that it's called a vinculum isn't really all that important. So the important stuff is the numerator and, of course, the denominator. So those are the important things for you to know. The numerator and the denominator. And a fraction, it's really just some form of division. So a fraction can be rewritten to look like this: 2 divided into 1, and that would equal 0.5 in decimals, but decimals are beyond the scope of this lesson, so we'll actually take a look at those in another video. Alright, the denominator simply tells you how many parts it takes to make one or a whole, how much is the entire amount, and the numerator tells you how many parts you have. And here we have 1 of 2 parts, and here we have 2 of 2 parts. And any time that you have the same number in the numerator as in the denominator, it is equal to 1. So here we have 2 over 2, that's equal to 1. 5 over 5, or 5/5, it's equal to 1. 9/9, it's equal to 1. X over X, it's equal to 1. So why is it that 1 over 1, or 2 over 2, or 9/9 is equal to 1? Well, 5/5 is equal to 5 divided by 5. And 5 will go into 5 one time. In a long division format, it would look like that. 9/9, it's the same thing as 9 divided by 9, and that equals 1. Long division form, 9 goes into 9 one time. Why is it that x over x is equal to 1? Well, it's just x divided by x, whatever x is, and that's equal to 1, and in long division format it looks like that. So let's take a look at addition, and that is, we have the numerator of 1 over the denominator of 2, that's 1/2, and 1/2 plus 1/2 is equal to 2 over 2, because you simply, when you're adding fractions, you simply add the numerators, because the denominators here have to be the same, and we'll talk about that shortly. So 2 over 2, you already know, is 1. So looking at that graphically, we have 1/2 of a circle plus 1/2 of a circle equals 1 entire circle. Alright, in order to add the fractions, the denominators must be the same, and you'll produce a denominator that's the same. In other words, 2 plus 2 is not 4 in this case. A denominator of 2 and a denominator of 2 remains a denominator of 2. And so then you just simply add the numerators. So 1 plus 1 is 2, and the denominators stay the same. You do not add them. So you already know that 2 over 2 is equal to 1, so we'll move on. So what do we do first here? Well, you take a look and you see, all the denominators are the same. We have 1/8, 3/8 plus 2/8. I simply then would come in and add the numerators. So 1 plus 3, that's 4, plus 2, that's 6, and then you have 6/8, and 6/8 will reduce to 3/4. However, reduction is a little beyond what we want to cover right now. Alright, so all the denominators must remain the same, or be the same, and then you simply add the numerators. What do you do when the denominators are not the same? Well, here we have 1/2 plus 1/4. The denominators are not the same. But what I've done is I've drawn a box, and then I've cut it in half. Half of it's red, and half of it's not. Then I have the same size box, and I've cut it into 4 pieces, so this would represent 1/4, and this would represent 1/2. So how do I add 1/2 plus 1/4? The denominators aren't the same. I simply will come in, and I can see that I can cut the 1/2 into 2 pieces, and that would give me 1/4 plus 1/4. And 1/4 plus 1/4 plus 1/4 is 3/4. 2 plus 1 is 3/4. And so you see I have 2/4 plus 1/4 equals 3/4, and there we have a graphic representation of that. Let's take a look at 2/3 plus 2/6. The denominators are not the same. I have to get the denominators to be the same. Well, turns out that 2/3 can be turned into 4/6. This is the same number. It represents the same value. But I have now, in looking at this, can see, well, the common denominator that the two would have, the least common denominator in this case, would be 6, because if I double the 3, I get 6, and if I double the 3, I then have to double the numerator and get 4. So 4/6 and 2/3 are the same thing. Now, it's pretty straightforward. I simply then just come in and add 4 plus 2 is 6, and I keep my denominators the same. They're 6, and you know that 6/6 is equal to 1. Alright, let's take a look at 1/2 plus 1/4 plus 1/8. The denominators are not the same. So, what do? Well, I have to turn them into the least common denominator, and in this case I might recognize that 8 seems to be the least common denominator, the smallest number that they will all fit into, and that is 4 will go into 8 2 times, so this would become 2/8, and 2 will go into 8 4 times, so this would become 4/8, because if I multiply this times 4 and I multiply the numerator times 4, I'll get 4/8. So I have 4/8 plus 2/8 plus 1/8, and then I simply just add 4 plus 2 is 6 plus 1 is 7, and I keep the 8's the same. That's 4/8. Subtracting with fractions, it's the same thing. You have to have the denominators line up, and they have to be the same. So I have 1/2 plus 1/4. I might recognize that 2 will go into 4 an even number of times, so it's 2 times. So 1/2 becomes 2/4, and then I will have 2/4 minus 1/4, and so it's straightforward on that. I have 2 minus 1 equals 1. I'm dealing with fourths. It's 1/4. You can check yourself with this by saying, okay, this number plus this number should equal that number. So 1/4 plus 1/4 does equal 2/4, and that's 1/2. Alright, now let's take a look at 1/2 minus 1/4 minus 1/8. We will subtract from left to right, and we'll see that we have to get the common denominators, or the least common denominator that's here, and it looks like it's going to be 8 in this case. So 1/2 becomes 4/8, 1/4 becomes 2/8, and I just bring the 1/8 down. Now I simply subtract 4 minus 2 is 2, 2 minus 1 is 1, and I wind up with 1/8. Alright, multiplying with fractions. It's exceedingly easy because the denominators do not have to be the same, and so it's pretty straightforward. We simply then just multiply the numerators. In this case, 4 times 2 is 8, and 7 times 3 is 21. And 8 over 21 will not reduce any further, so that's the least that we can do that. We could turn it into a decimal, however, that's beyond the scope of this lesson. Alright, more with multiplying with fractions. We're simply going to take 4/3 and multiply that times 7/2. We simply then just multiply 4 times 7, and that gives us 28, and then we multiply 3 times 2, and that gives us 6, and then we look at that and think, that's an improper fraction. We're going to have to turn it into a proper fraction, and it could be reduced some. So improper fractions will be discussed later in the video, but if you were to take a look at this, you might see that, okay, I can simply cut 28 in half and 6 in half to wind up with 14/3. Now, 14/3 turns into 4 2/3, but we'll take a look at how that happens shortly. Alright, dividing with fractions. Well, I have 1 divided by 1/2, and that equals 2. 1/2 will go into 1 2 times. So how do you divide with fractions? It's pretty straightforward as well. We simply turn over the fraction, so 1/2 becomes 2 over 1, and then it's multiplication. 1 times 2 equals 2, and there's an implied 1 here, so 1 over 1. times 1 is equal to 1, and you should know that any number over 1 is that number, and that happens to be 2. So that's what we got up here. So let's take a look at another example. 4 divided by 1/3 equals 12. In other words, 1/3 will go into 4 12 times. Well, let's write it this way. 4 divided by 1/3 equals the same thing as 4 times 3 over 1, and that equals 12 over 1, and that equals 12. Improper fractions. Improper fractions are when the numerator is larger than the denominator. In this case, any number over 1 would equal that number, so we have 2 over 1, which is 2. How many times will 1 go into 2? It'll go 2 times. Let's take a look at 7/3. How many times will how many times will 3 go into 7? 3 will go into 7 2 times. That will be 6. 2 times, so that's 6. And 6 minus 7 is 1, so we wind up with 2 and 1/3. You can check yourself this way by simply saying, okay, will 3 times 2, that's 6, plus 1, that's 7, that's 7/3. Alright, let's take a look at 9/2. How many times will how many times will 2 go into 9? It will go 4 times, and 4 times 2 is 8. That would leave us with 1/2 left over. 1 over 2, we're dealing with halves, and so that would give us 4 and 1/2. You can check yourself by saying 2 times 4 is 8, plus 1 is 9. We're dealing with halves. Alright, 12/5. How many times will 5 go into 12? It will go 2 times. That will create a 10. 12 minus 10 then is 2 left over, and so we wind up with 2 and 2/5. You can check yourself by saying 5 times 2 is 10, plus 2 is 12, and we're dealing with fifths, 12/5. Okay, now you've been through the intro lesson on fractions, so now you can take the practice test via video. If you don't see the practice fractions lesson as an option to the side, you can enter the words that are above in red in the YouTube search bar. That's practice fractions lesson. Alright, your comments, questions, and suggestions are welcome, encouraged, and appreciated. You may contact me at alanmorris@yahoo.com.